I am Mr. Ish and I welcome you to this video. It should not be a long video because we're here focusing only on this concept of median of a probability density function. You know there are three measures of centrality. One is mean, median, and mode. We're looking here at the median, which is representing normally the middle of a sample of values. You have a specific sample of values, you arrange them in order, you determine the median. You're basically determining the middle of that sample. When we're talking about probability density functions, this right here very well stems off from the material I presented in the direct previous video to this, where we were looking in that regards to a waiting time. We're making a phone call and waiting how long to see, or what's the probability that a certain person phoning would wait to speak to customer service. And we remember this was the function we presented in that specific video. F of t was equal to 0 for those values less than 0 t time, and it was equal to this specific function where the values were greater than or equal to 0. This symbol over here representing mu was the mean of that probability density function, and in that specific example it was 9 minutes. What is the median of the function that is present before you? So this is like another question off of that previous example from the previous video, but we're looking here at median. With regards to the probability density functions, this median is a measure of centrality of a function, such that you can say that half of all the values in your sample, they will have that specific quality it is that is being investigated, the specific quality that your continuous random variable is examining, such that half of the values will be before it and the other half of the values will be after it in terms of that median of that function. The best way to determine the median of a function is to look at it in terms of this. You see this right here is your median. We can write it as this. It's looking at it in this form. From your median value up to infinity, you have a certain function f of x dx, and it'll always equal to half. If you were to integrate it, it would always equal half, and that's exactly what we're talking about. In this specific video, we're looking here at this. If the mean of that probability density function is 9 minutes, what is the median of that function? And the function is right here before you. When you put this mu right over here, you're looking at 1 over 9. You're putting 9 here in places of mu, e to the power of minus t over 9. And that right there is your function, 1 over 9, e to the power of minus t over 9. So you have to integrate it such that you will employ this format right over here. Remember, when we're looking at a probability density function with regards to this median, right here, the median, if you were to graph it something like this, it doesn't have to represent that specific function, but just in very general, you're looking at everything from here to right over here. This entire area here is being examined in terms of the area below the curve. If you are to determine the median, if this might be the median, you have half of the area over here to the left of that median, and you have the other half to the right of that median. That's how the median works. It splits everything into two parts. So let's examine in this video what the median of the function is, and this right here is my function. The mean is 9. So the situation is this: you're making a phone call and you want customer service to get a hold of you. What is the median wait time? What will that be? The actual definite integral part is not hard. We know we have this function, we can push the 1 over 9 out. We know we're looking for this value m, the median, it going up to infinity. The function, as you remember, is e to the power of minus t over 9 dt. That exactly is our function. We have to solve this, and we know in terms of the median it equals to half, because half the values are always located after the median, the other half are always located before the median, because again the median in terms of centrality measure represents the middle of your sample of values. Therefore half must be after, half must be before. You have to do polynomial substitution. If u is equal to minus t over 9, du is equal to minus 1 over 9 dt, dt is equal to minus 9 du. You have a new set of u1 and u2. This right here represents my t1, t2, then you have u1, u2. Everything with regards to minus t over 9, you'll have a minus m over 9. Here u2 will be a minus infinity over 9, which is just a minus infinity. That divided by 9 is meaningless in the face of infinity. When you plug everything in, you have this minus 9 coming out, because you know it's a minus 9 du. You have everything here from a minus m over 9 up to a minus infinity, e to the u du. We have a smaller number here in the upper limit, a larger number here in the lower limit. That's not very interesting. We have all of this coming out here, which is equal to a minus 1. Minus 9 times 1 over 9 is a minus 1. If we bring in another minus, we can flip these intervals around. And you know that's a good property of definite integral. So we can flip all of this around and we can bring the minus m over 9 here, and we can bring the minus infinity down here, and by means of this minus minus cancels out. So this is what we're left with: minus infinity up to minus m over 9 e to the u du, and let's integrate this to arrive at that median value. All of this of course equals 1 over 2. The antiderivative of e to the u is just e to the u. You have minus m over 9 and you have minus infinity equaling 1 over 2. Upper limit, lower limit, the difference of the two, e to the minus m over 9 minus e to the minus infinity is equal to 0.5. And that's exactly what it is. You know e to the power of minus infinity is a 0 because you're looking at 1 over e to the infinity, which is really a 0, a numerically very small value. It's equal to a 0, and you can just remove it. You can bring in the properties of logs. You have minus m over 9 natural log e is equal to natural log 0.5. Now this part right here is not hard. You just bring your calculator, do a natural log of 0.5 and multiply that by negative 9. You'll solve for your m. M here is 6.238. I'll bring the value right over here. M is equal to 6.238. What does this mean? 6.238 minutes. For this specific function, and in terms of what it represents, a specific customer calling customer service, the median wait time is 6.238 minutes. Any person calling, or a number of people calling, or the total number of people calling, half of them will wait longer than 6.238 minutes. The other half of those entire sample of callers will wait less than 6.238 minutes. Hence this represents a median value, and you know all of this is very well determined by this specific integral from m up to infinity. You have f of x dx. The definite integral outcome is always here a 1 over 2, because the 1 over 2 represents the middle of that sample of values. Whatever it is that is being investigated or examined, the median represents the exact middle. So when I'm calling or you're calling, there's a 6.238 minute median wait time, and then it's not talking about the probability here. We're just calculating the median wait time. The probability would of course be, as I presented in the other video, a different matter, but this gives you an indication of the median wait time, the exact middle of that entire sample. And that's the crux of this video over here. Hopefully you find this interesting. Thank you for watching. I hope you all have a great day. Bye.